got a new problem up on the board. This time y is f of x is 1 over x cubed plus 2, and we're asked to do two things. First of all, we're asked to find f prime of x, the derivative function, and I'm just telling us that we could also call that y prime. So just like the function, we can call it f of x, or we can call it y. Using this prime notation, we just attach a prime to the name of the function, and that gives us a name for the derivative. So f prime of x, or also y prime. And we'll see there's a lot of notation that we can use. These are just two of the options. Once we've done that, we want to find the slope of the tangent line when x is negative 3. I do want to just point out, we're just asked to find the slope. In the last couple of videos, we were asked to find an equation for the tangent line. Those questions are very related, because in order to find an equation, I would need to find the slope first and then use it to build that equation. But do make sure that you're reading the questions carefully and actually answering the question that you were asked. All right, so if I want to do this, I always like to have a picture. I was thinking of this, by the way, as one that we do together, but if you prefer to try to work this out on your own, feel free to pause the video and do that. Now, I can actually get a picture fairly quickly. I can see I would have a vertical asymptote when the bottom is 0, because the top never is, and the bottom would be 0 at negative cube root of 2. Other than this looks basically like the reciprocal of x cubed. We've just shifted it over a little bit. Okay. And so my graph looks something like this. Now, if you're comfortable with that, great, because that gives you a place where you can put your points. If you're not comfortable with that, or if you just don't feel like taking the time to figure that out, but you just kind of like having a place to put your points, it's totally fine to just graph a generic function and make a note, if you do that this is not at all accurate. You were not trying to graph that function. You were just trying to give yourself a place to put your points. So our point of tangency will be x, 1 over x cubed plus 2. And I can put that on my graph. And then I'll have a nearby point, which I'll call x plus h. And then for the y value, I want to recognize that I'm just replacing x in my formula with x plus h. So it would be 1 over x plus h, the quantity cubed, plus 2. Same thing here, x plus h, comma 1 over the quantity x plus h cubed plus 2. Okay, now important differences between these pictures. This one is vaguely accurate, this one is not remotely accurate. What that means is when I get to this point here, I can see that when x is negative 3, we're somewhere over here on this part of the graph. I can see we're going down, so I know that I should get a negative answer to part B. If I don't, I'm going to want to go back and check my work because I'll know I made a mistake somewhere. Since this graph isn't accurate, I can't use it to see whether my slope at negative 3 should be positive or negative. All right, so now if I want to get y prime or f prime of x, just getting used to the options in the notation, I know that's the limit as h goes to 0, as I move this point closer and closer to that point of tangency, of the slope of the secant line, which is 1 over x plus h cubed plus 2 minus 1 over x cubed plus 2 all over h. Now, I am going to need to eventually multiply out x plus h cubed. I'm going to procrastinate on that just a little bit and do that a little bit later, although it would be perfectly acceptable to do it now. I'm going to observe that I have a complex fraction. I've got fractions inside of fractions here. And there are two basic ways to deal with that. One is I could find a common denominator, combine the fractions on top into a single fraction, and then use the fact that dividing by h is the same as multiplying by 1 over h. Perfectly fine. What I think is a little bit faster is to use this lovely technique of just multiplying by a fancy form of 1. What I'm going to do is I'm going to multiply by 1 in the form of the product of these two denominators. So that would be x plus h cubed plus 2, that whole thing times x cubed plus 2, and then over itself, so that I'm just multiplying by 1. Now, the reason that's helpful is because I've got to distribute this to both terms on top. But when I distribute to the first fraction, that first factor, which happens to be the first denominator, just cancels. So what I'm left with is just x cubed plus 2. And then I'm going to be subtracting, and I'm going to go ahead and put some parentheses here, because I'm subtracting the whole thing that I get from the second fraction. But when I distribute this to the second fraction, the denominator of that second fraction cancels. So that what I'm subtracting is x plus h quantity cubed plus 2. And then that's all over h times this product, x plus h cubed plus 2 times x cubed plus 2. Okay, now I know I'm hoping to be able to cancel that h on the bottom. So I'm going to need to work out what I have on the top in order to be able to hopefully factor out an h. So to do that, I'm going to need to know what x plus h cubed is. So let's just do a little bit of side work here. X plus h cubed, I could just multiply that out. That's 3 factors of x plus h. But there's a nice shortcut, if I prefer, and that's to use the binomial theorem. Binomial, remember, is just a polynomial with 2 terms. Here my 2 terms are x and h, and they're 2 terms that are connected by addition. The binomial theorem gives me a way of taking positive integer powers of binomials like that are just a sum of 2 terms. Okay. Now, what it says is I'm going to get some terms that are x cubed. I'm going to get some factors of x squared times h, some x times h squareds, and some h cubes. Basically, as I multiply this all out, I'm going to get a bunch of terms that involve factors of x and factors of h. And the rule is the types of terms I get, since it was x plus h cubed, all of these terms have to have a total of 3 factors, and they're either x's or h's. So I start with all 3 factors being x's, which means there aren't any h's. Then I go to 1 less x, so I just have 2 factors of x, but then the third factor has to be an h, so that I have a total of 3. If I have 1 less x, I'm going to have the other 2 factors being h, and then if I don't have any x's, all 3 factors are h. So those are the types of terms. To figure out what the coefficients are, I can use Pascal's triangle. We start with 1 and 1. Notice, if this were an exponent of 1, if it was just x plus h to the first, that would be 1x plus 1h. These are the coefficients. To form a triangle, I go out on either side, and to fill in the middle, I just add in. Anytime I've got a pair of numbers above a blank spot, I add that pair. I'm going to continue to the third row, since I want the third power. So it starts and ends with a 1. It's going to give me a 3 and a 3. So these coefficients are 1, 3, 3, and 1. Okay. Now, I think it's faster to use the binomial theorem than to actually multiply that out. That's up to you. We will need to use the binomial theorem in the next section. Okay, so nice to review it just a little bit here. Okay. So what I'm going to do is now, I want a bigger board. I'm going to erase this, okay, which just multiplied out the x plus h cubed. And now I'm going to return to simplifying this limit. Okay. So it's the limit as h goes to 0 of x cubed plus 2 minus, in parentheses, and I'm just going to substitute in what x plus h cubed was. We just saw that was x cubed plus 3x squared h plus 3xh squared plus h cubed. That's this part right here. And then the plus 2. And then that's all over h times, here I'm actually going to just keep that as x plus h cubed plus 2. Because here I don't really need to do any more simplifying with that part of things. The rest of the bottom here, these two factors, are basically just going to hang out until I'm able to cancel that h. All right, so now I want to distribute that negative on the top. So this is going to equal the limit as h goes to 0 of x cubed plus 2 minus x cubed minus 3x squared h minus 3xh squared minus h cubed minus 2. All of these terms become negative over h times x plus h cubed plus 2, that whole quantity, times, whoops, that's an x cubed plus 2. Okay, so let's see what cancels on the top. Here's an x cubed and a minus x cubed. Those cancel. Here's a 2 and a minus 2. Those cancel. Notice everything that's left on top has an h in it. So I'm going to go ahead and in my next line, I'm just going to factor out an h from the top. So here that's going to leave me negative 3x squared minus 3xh minus h squared, all over h times x plus h quantity cubed plus 2 times x cubed plus 2. And we can cancel the h's. Now once we cancel those, I still have a lot of h's here. I've got h's up here, I've got an h on the bottom, but it's not an h by itself. It doesn't make the entire denominator go to 0. So I can now plug in 0 for h. So this is negative 3x squared minus 0 minus 0, because the terms with h's in them go to 0, all over x plus h becomes x plus 0 cubed plus 2 times x cubed plus 2. Notice, as long as I still had h's in my expression, I was writing the word limit as h goes to 0. Once I plugged in 0, I was able to drop the word limit. Okay. So I've got negative 3x squared over, notice this just becomes x cubed plus 2, and then I've got another x cubed plus 2. That's x cubed plus 2 quantity squared. So that is my formula for f prime of x, or equivalently y prime. Okay, so now we were asked in part B to find the slope of the tangent line when x is negative 3. So that's just f prime evaluated at negative 3. I'm plugging in negative 3 for my x's. So that's going to be negative 3 times negative 3 squared over negative 3 cubed plus 2 quantity squared. So let's simplify that. Negative 3 squared is positive 9 times negative 3 is going to be negative 27 on top. Negative 3 cubed, and I'm sorry, that negative 3 should have been in parentheses. That's negative 27 plus 2 is negative 25. Squared is going to be positive 625. So that's my derivative at negative 3. Okay. One little bit of notation. If we're using the f prime of x notation, we've got a place to write our input. If I'm using the y prime notation, and I want to indicate that I want to evaluate that at negative 3, I can just write a vertical bar here, and then the number negative 3. This is what we call an evaluation bar. So when you've got a function, and its name doesn't just come with a place for the input, you can write the name of the function evaluated at, and then the input that you're going to plug in. That's the same as f prime of negative 3, which we just determined is negative 27/625.